What's happening, guys? My name is Nicholas Renat, and in this video we're going to be taking a look at machine learning classification using a library called PyCaret and Python. Now, in terms of machine learning classification, this falls into the category of supervised learning, and normally when you're trying to predict classification, you're trying to predict a label. So 0 or 1, true or false, yes or no. You might be banding things into different categories. Now, there's a whole heap of different use cases when it comes to actually leveraging classification. So say, for example, you wanted to predict customer churn. You want to predict whether or not someone has a particular condition or not from a health or medical standpoint. If you wanted to predict whether or not someone's likely to click on an ad, there are a whole heap of different types of possibilities. Even sentiment analysis can be formed into a classification problem. On that note, let's take a look as to what we'll be going through. So first up, what we're going to be doing is we're going to be installing the PyCaret library. And then what we're going to do is load up some custom data from Kaggle. So we'll specifically be using a heart disease data set. So predicting whether or not a particular person does or doesn't have heart disease. So in this case, it's a binary classification problem. And then what we're going to be doing is using the PyCaret classification classes to be able to go and build up an automated classification model. Let's take a look as to how this is all going to fit together. So first up, what we're going to be doing is installing PyCaret. This is relatively straightforward using a pip install. Then we're going to load up some data from Kaggle. So we'll download our data set and then bring it into our notebook. And then last but not least, we're going to go through all the different processes that you've got available using the PyCaret classification module. So that will allow us to build our classification model that's able to predict whether or not a particular person has heart disease based on a number of features. Ready to do it? Let's get to it. Alrighty, guys, welcome to the PyCaret classification crash course. So we're going to be going through this relatively quickly, and I'm going to be giving you sort of a bird's eye view as to how to actually build a classification model using PyCaret. Now, all in all, we're going to have roughly 5 steps that we need to go through. So first up, what we're going to do is install and import our dependencies. Then what we're going to do is load in some data, and specifically, we're going to be grabbing our data from Kaggle. Then we're going to train and evaluate our model. The nice thing about PyCaret is that it makes this super easy. So you'll be able to actually do this relatively quickly. Then what we'll do is we'll actually go on ahead and test out our model. So we'll actually be able to pass through some testing data and actually test this out. And then last but not least, I'll show you how to save down your trained machine learning classification model to be able to leverage it going forward. So first things first, what we need to do is install and import our dependencies. So there's 3 key dependencies that we're going to need in this particular case. Those are PyCaret. Obviously, we need it to actually go and perform our ML. Then we're going to be using Pandas, and Pandas we're specifically going to be using in order to read in our data set to be able to build a custom machine learning model. And then last but not least, we're going to be importing SHAP as well. So SHAP helps us with our machine learning model interpretability. Now, what we're first up going to go on ahead and do is install those dependencies. So let's do it. Okay, so that is PyCaret, Pandas, and SHAP now installed. So in order to do that, what I've gone and written is !pip install PyCaret, Pandas, and then SHAP. So PyCaret is going to be our main machine learning library that we leverage in order to go on ahead and perform classification. Pandas is going to serve as our tabular data processing library. So again, Pandas super popular. So if you haven't seen my Pandas crash course, I'll include a link somewhere up above so you can take a look at that. So again, just gives you a little bit of an idea of the basics. And then SHAP is a core dependency of PyCaret when it comes to interpretability. Now, again, key thing to note is that I'm going to be doing a bird's eye level view of PyCaret today. So there is a whole bunch of stuff that I'm not going to be showing in this video. But if you'd like to see a deeper dive or perhaps a full-blown PyCaret course, do let me know in the comments below. I'd love to hear your feedback. The goal of today is to ideally build a custom ML model. So, cool. Those are our dependencies now imported. So first up, what we're then going to do, or next what we're going to do is actually import these dependencies into our notebook. So let's do it. Okay, so we've gone and imported our dependencies. So we've just gone and written 2 lines of code there. So first up, import pandas as PD. And then the second line that we've written is from PyCaret.classification. So we're going to be importing from the PyCaret classification module, import star. Now, a cool thing to note is that PyCaret's got really good documentation around it. So if you actually go to PyCaret.org, there's a whole heap of information as to how to get started. And this is probably summarizes PyCaret really well in a nutshell. So PyCaret is an open source, low code machine learning library in Python that allows you to go from preparing your data to deploying your model within minutes in your choice of notebook environment. So there's a whole bunch of stuff that you can actually do with PyCaret. So specifically, we're going to be using the classification module, but there's a whole bunch of other stuff that you can do. So classification is typically to do with predicting a label or a categorical label. So 1, 0, true, false, churn, yes or no, high value, medium value, upper value. So again, it's all to do with predicting labels. So regression is all to do with predicting continuous variables. So think house prices and sales, salaries. Clustering is all to do with predicting stuff that are liked or grouped together. And you've also got anomaly detection, NLP, and association rules mining. I won't go into those into too much detail, but again, it just sort of shows you the scope of PyCaret. And again, if you'd like me to do more on this, let me know in the comments below. Always want your feedback. So what we're now going to go on ahead and do is actually load up our data. So we've now gone and done our import. So import pandas is PD, and then from PyCaret.classification, import star. What we then need to do is go to step 2, load our data. So that's step 1 now done. We're up to step 2. So what we're going to do in order to bring in our data is we're actually going to grab some data off Kaggle. So in this case, you can see that we've got this heart disease UCI data set here. And we've got a whole bunch of columns in this particular data set. Now there's one which is particularly interesting to us, and that is let me just select them all so you can see them. That is this column all the way to the far right, which is called target. So what we're going to be trying to do is predict a binary outcome. So 1 or 0, true or false, right? So in this particular case, the 1 means that that particular person has been predicted as having or has been identified as having heart disease. 0 identifies them as not having heart disease. So ideally, we're going to be trying to predict that particular outcome. Now, we've also got a number of different features available in this data set. So we've got age, sex, chest pain type, resting blood pressure, serum cholesterol, fasting blood sugar, resting ECG results, maximum heart rate. So a bunch of a whole heap of different medical related features which are attributed to having some impact as to whether or not a particular person has heart disease or not. So we're going to be using these features to try to generate that predicted outcome. So what I'll do is let's go on ahead and download this data set from Kaggle. So we can just hit download from over here. And then we can grab that data set from our downloads folder. In this case, it's called archive3. And if I extract that, you can see we've got a data set called heart. So if we copy that over and bring that into our core folder and paste that in. So this is in the same folder as the Jupyter notebook that I'm working on. So this is the notebook that we're currently working on. This is going to be our data set. So what we can then do is actually read in this data set into our notebook using pandas and actually start working with it. So let's go on ahead and do that. So again, to load in data using pandas, relatively straightforward. So we're just going to create a variable called df, standing for data frame. And we're going to type in pd.read underscore CSV, and then the name or the full path to our data sets. In this case, it's heart.csv. Yeah, and I've written that line a few times in my career. So pd.read.csv allows you to actually bring in data into your notebook. So in this particular case, we're reading in our heart data set. Now, in order to look at it, we can use some basic pandas functionality. So I'm going to type in df.head to view my first 5 rows. We can close that. And you can see that we've got all those columns that you saw that we had inside of Kaggle. So we've got all of these columns here, all of those columns there. Now, key thing to note is that some of these columns are going to be categorical, but they've probably been read in as numeric features. So if we type in df.dtypes, you can see that right now, a lot of them are actually flagged as numeric. So I've gone ahead and identified which ones I think should be categorical. So we're going to go on ahead and set up a parameter for that inside of step 3. So we've got age, sex, CP, which I believe was chest pain. We've got resting blood pressure, cholesterol, a whole bunch of different medical related features. And we've got our target column, which is really, really important because this is going to be what we're trying to predict. So target. So that's our data now loaded in. Again, I'm going through this relatively quickly. So this is sort of some standard pandas functionality here. Now we're on to the good bit, training and evaluating our model. So there's 2 key parts of this. So first up, what we're going to do is set up an experiment. So the way that PyCaret works is based on this concept of an experiment. So think of this as 1 machine learning run, right? So you're going to set up an experiment, do a bunch of stuff to ideally build a model. So first up, what we need to do is actually set up this experiment. But before we do that, we first up want to identify which of these columns are going to be categorical. So let's go on ahead, and I'm just going to set up a quick list and actually pass through just the names of the columns that should ideally be categorical. So let's do this. Okay, so what I've gone and done there is set up a list called cat_features. So we've created a new variable called cat_features, and we've set that equal to a Python list or an array, really. And then to that, we've passed through all the names of the different columns that we want to be identified as categorical. So here I've identified sex as categorical because it's mainly ones and zeros. CP, that is based on this. So it's saying that chest pain has 4 different value types. What else do we have? FBS, which was fasting blood sugar. So in this case, we've identified that as categorical, and then we've gone and identified these other 3 as categorical as well. Now, what we can actually do is pass this categorical features parameter to our experiment when we actually go and set it up. And then PyCaret is going to treat those columns as categorical features going forward. So let's go on ahead and now set up our initial experiment. Okay, that is really it when it comes to actually setting up our experiment. So what I've gone and written there is experiment equals setup. So setup is going to be our main experiment function. So if we type in setup, question mark, you can see that there are a whole bunch of different parameters that you can actually go and set when you actually build up your experiment. But if we actually take a look, so the core component to it is, let's actually zoom in on this. This functionality initializes the training environment and creates the transformation pipeline. So think about this as like your machine learning environment, and your transformation pipeline is going to represent all the different steps that you go through to build your machine learning model. So it might be some data pre-processing, it might be some feature creation or feature engineering. So think of it as the steps needed. Now, the setup function must be called before executing any other function. It takes 2 mandatory parameters, data and target. Now, when I was actually experimenting with PyCaret, I was actually passing through a whole bunch of other parameters, but for now, we're just going to stick to the bare minimum. So we need to pass through data and our target. Now, that is exactly what we're doing here. So we are passing through df, which is going to be our data, and then we're specifying our target, and this is the target name. So in this case, our target name is target. So I've just set that equal to target. So if you've got a different data set and your target column is named something differently, you just need to make sure you pass through the data and then change the target parameter equal to the name of your column that represents what you're trying to predict. And then we've passed through one additional feature just to make sure we've got our features set correctly. And we are setting categorical_features equals to our cat features list that we set up here. So basically what we're saying is that we want PyCaret to treat these particular features as categorical rather than leaving them as numeric. So it's just sort of a bit of a backstop to make sure we treat them correctly. So if we actually go and run this cell now, it's going to give us a view of all of our different columns that we're going to be using. And if you're happy, all you need to do is hit enter, because you can see that you've got this little box there. If you're not happy, you can actually just type in quit and then hit enter, and it'll stop there so you can go and make the necessary adjustments. But for now, we're happy. We've got our categorical features set appropriately, and our target down the bottom there, which you can see there, is set equal to label. So this means that that is our target. So if I hit enter, that is our feature now done. And you can see it actually shows you all the different parameters that you've actually got the ability to go and set. So again, you can go and perform PCA, numeric binning, you can choose to remove outliers. So there's a whole bunch of different things that you can actually go on ahead and do. Now, again, we're going to go through this relatively quickly, but if you'd like to see more, do let me know. So that is our experiment now set up. Now, all that's left to do is actually go on ahead and train these models. So let's actually go on ahead and do that. Cool. So what I've gone and written now is best_model equals compare_model. So what this is actually going to go on ahead and do is train not one, but a whole heap of different machine learning algorithms to be able to predict our feature column, or our target column in this particular case. So what I've gone and written is best_model equals compare models. And if we run this is actually going to go on ahead and train our machine learning model. So down there, you can see that it's processing. And you're actually going to get a bit of a leaderboard. So it's actually going to show you the best performing model at a particular point in time. And once it's done, it's going to highlight the best performing metrics in this particular case. So from here, you can see that our ridge classifier is actually our top performing model. So it's actually ranked. So the first model or the first algorithm is actually the best performing model. So our ridge classifier is performing best, and then you've got all the others there. So what you're actually seeing here is a whole bunch of different types of machine learning algorithm. So ridge is a type of algorithm, LDA is a type of algorithm, logistic regression is a type of algorithm, naive Bayes, extra trees classifier, all of these are different types of algorithms. Now in this particular case, they're all able to actually go on ahead and predict our particular column, but we're interested in the one that's actually going to go on ahead and predict it best, which here is our ridge classifier model. So you can see that our accuracy is 0.8299. Our recall is 0.8788. Our precision is 0.838 or 0.8338. So in this particular case, a higher accuracy number is better, higher recall number is better, higher precision number is better, higher F1 number is better. And you've also got the test time, I believe. So in this particular case, I believe a lower test time would be better because it means that it's actually able to test a whole heap faster. Now, in this particular case, by actually setting our compare models function equal to best model, we're actually able to access our best model using that best model variable. But if we actually take a look at what we've done so far, we can delete this setup column. So what we've gone and done to train and evaluate our models is we first upset our categorical features. We then went and set up our experiment using the setup method. And remember, you only need to pass through two key arguments there, your data and your target. But we've gone and passed through what our categorical features are as well. And then to train it, you just run compare model. So again, if you actually take a look at what we've written so far, so there's two lines there. So 1, 2, 3 to read in our data. Those are optional. 4, 5, 6. So 6 lines, and you've actually gone and built a machine learning model. So again, you can get up and started with this reasonably quickly. Now, the next thing that we want to do is actually go on ahead and test our model. Now, I'm just going to test it on the last 5 rows of data. You might want to do a better train test partition, say, for example, with the train test split method from scikit-learn. We're going to keep this reasonably simple. So let's go on ahead and do it. So in order to test our model or in order to make predictions, we can pass through predict_model. And then to that, we pass through our best model and then the data that we actually want to predict on. So if I pass through, if we actually didn't pass through any data, it's actually going to go on ahead and test on our testing partition. So you can see here that it's gone and passed through all of this data. We've got our target and we've actually got our label. So our label represents our predicted column. So in this case, this label is our predictions. We go and pass through a different data set, so df.tail. So you can see it's doing the exact same thing there. So let me quickly explain that in a little bit more detail. So in order to go and make predictions during our experiment, we're able to use predict_model. And then to that, what we want to do is pass through the model that we want to generate a prediction from. Now, you can also generate a prediction from any of these different algorithms that you see here as well. But in this particular case, we're using our best model. So we've written predict_model, we've passed through best_model, and then we've passed through the data that we want to predict on, which in this case is our last 5 rows of data. So we've written df.tail. Now, what we could also do is drop our target column. So if we wanted to do that, we can type in df.drop and then pass through the column we want to drop. So it'll be target and pass through axis equals 1. Axis equals 1. Yes. And then pass through .tail, so then you won't actually have your target column there. So again, this sort of represents what you might actually do in practice if you had a testing partition, because you drop your target label. But in this case, you actually want to see the difference. So if we take that off, you can see that in this case here, so let's take a look at our data. So for row 298, the actual value was 0. So that person didn't have heart disease, and it predicted that the person wouldn't have heart disease. For 299, the person didn't have heart disease, and it predicted that it did have heart disease. So that would be a false positive. In this particular case, 300 and 301 were fine. 302 looks like a false positive as well, because in reality, the person didn't have heart disease, and our machine learning model predicted that they would. So again, you can start to see how to actually evaluate these models. Now, what we've gone through is how to actually make new predictions. Now, the last thing that you might want to do is actually go on ahead and save this model. So let's save it down. So all we need to do to save our model is save model, pass through the model that we want to predict. which is, in this case, is going to be best model, and then the name of the model. So we're going to call it Ridge model. Yep, this should be model name. And there you go. That's our model now saved down. So if we actually take a look here, you can see that it's actually gone and saved this down as Ridge model. If we delete it and generate it again, you can see that it's saving our model down as a pickle file. So this is a serialization library that actually allows you to save your models down to disk. So that is our model now saved. Now, if we wanted to load it back up, we can type in load models or load model and then pass through the name of our model, which in this case is Ridge-model. And that is our model loaded up. Now we can store that inside of a variable called model. And if we wanted to make new predictions, let's go on ahead and do it. So we can type in model.predict. So this is more like how you might actually do it in practice when you actually go and deploy this. So model.predict and then pass through our data. So we'll pass through df.tail. And there you go. So we've now got our predictions again. So this is returning a set of labels. So 0, 1, 0, 0, 1, which is exactly what we had up here. So 0, 1, 0, 0, 1. And that in a nutshell is how to get started with PyCaret. So we've gone through a bunch of stuff really, really quickly there. And again, if you'd like me to do this in more detail and maybe at a slower pace, do let me know in the comments below. We can go through this in a lot more detail. But in a nutshell, what we've gone and done is installed and imported our dependencies. We then went and loaded our data using some Pandas functionality. Then if we take a look at our core PyCaret functions, setup creates our experiment, compare underscore models trains and compares our different models, predict underscore models actually allows us to test our models, save underscore model allows us to save our models down. And to that, you just need to pass through the model you want to save and then the model name. And then last but not least, load underscore model allows you to load your model back into memory. And that about wraps it up. Thanks so much for tuning in, guys. Hopefully you enjoyed this video. If you did, be sure to give it a thumbs up, hit subscribe, and tick that bell, and let me know what you thought of classification with PyCaret and what you ended up using it for. Thanks again for tuning in. Peace.